In this lecture, we're going to see what's going to happen if you try and use a const object as a function argument. We're going to be using the same class we've used in the last lecture, no change at all. We're going to have a few constructors and we're going to have the setters and getters, and we're going to have a printful function. And we're going to have our member variables, which are going to be modeled as a string view variables, and the age is going to be a row int variable. So it's not going to be quite like this, but it's going to be exactly like what we did in the last lecture. The main thing we want to see is what happens if you use a const object as a function argument. And we're going to have a couple of options. We could either pass by value, we could either pass our parameters by non-const reference, we could pass by const reference, we could pass by pointer to non-const, or we could even pass by pointer to const. So I want you to pause the video and try to think about what could happen in each of these cases if we pass a const dog object as a function parameter. Try to think about it, and then I am going to tell you. The first case is going to be passing by value. And here we have a simple example of that. We have a function called function taking dog. It's not going to return anything, and it's going to take a dog object by value. Inside, we're going to try and set the name and print the information, and this is what the function here does. In the main function, you see we have a const dog object, and we're going to pass it by value. The thing is, this is going to work, because what we really have inside the function is not the original variable. It's a copy, and we won't have any problem trying to modify a copy because the constness of the original object is going to be preserved. We're not going to be modifying it. We're going to be modifying a copy. So passing by value is going to work fine. So what if you pass by non-const reference? Here we have another simple example. We have function taking dog ref. It's not going to return anything, but it's going to take a dog object by non-const reference. Notice that we don't have a const in front of the dog parameter here. So this is a non-const reference. The compiler is not going to allow this because this reference could be used to modify the original object. So this code here won't even compile. And the reason is because our object is const, we're not allowed to do any modification on this object, and we are trying to pass that to a function by reference, which could allow us to potentially modify this object. The compiler is going to prevent us from making a call like this. Okay, so this is not going to compile. If we pass by const reference, things are going to be improved a little bit. The function is going to be set up like this. It's going to be called function taking const dog ref. It's not going to return anything, but it's going to take the parameter by const reference here. We have a const. This is going to protect from modification from this reference here. So if we didn't have anything in the body of the function, the code here could compile. But the problem is going to come if we try and do any modification here. For example, if we call set name here, we're going to be prevented from doing this from this const reference because it is a const reference. We can't go through it to modify our object that we are referencing, but the call to printful here is also not going to work. And this is the exact same thing we saw in the last lecture. The compiler doesn't really know that the printful function isn't modifying our object, but we know that. But the compiler doesn't know that. That's the problem here. And the compiler is going to throw a compiler error if we try to call the printful function from our reference here. So we are back to the same problem in the last lecture. Our dog object that we pass by reference here is really going to be useless in this function body here. We can't read from it. We can't write to it. We can't basically do anything with it. So passing by const reference isn't really going to work for you either. Okay, passing by reference isn't really working for us. What about passing by pointer? Well, I hate to disappoint you, but this is also not going to work. Here we are passing by non-const pointer, and this pointer could be used to modify the original thing we are pointing to. So the compiler is going to prevent the call like this to even compile because we are passing an address to a const object, and the pointer parameter here could be used to modify that object. So we're going to get a compiler error if we try to compile this function call. This is not going to work either. Okay, so you might be saying, what if we pass our parameter by pointer to const? And here we have an example doing that. The function is not returning anything, and it's taking its parameter by const dog pointer. So the compiler is going to allow the signature here to compile, but if we try to do any modification inside, we're going to get a compiler error on our setter here, and this is expected because this is a pointer to const. So we can't go through this pointer to modify the object we are pointing to, but the call to printful here is also not going to work because the compiler thinks printful here could be used to modify the object we are pointing to, but that object happens to be const. So we really are not allowed to modify that, and the compiler is going to do everything it can to protect the constness of this object here. So hopefully you can see that even in function calls, const objects can be problematic to work with because the compiler is not going to allow us to read or write through the object, and the object is basically going to be useless in our eyes. So now that you have an idea about these problems, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is const objects as function parameters. We're going to grab the code from the last lecture because we're going to be using that as a starting point. We can grab the class header and CPP file and the main function. Let's copy that and use that in our current project here. So we're going to do that, and we don't want to forget the VS Code folder, which is going to bring us the settings we can use in our project. So let's go back to our project here and make sure we have this .vs code folder in. Once we have it set up, we're going to open it in Visual Studio Code by dragging and dropping here. This is going to open our project. You see we have the main function, we have our dog class, which lives in the header, and the CPP file here. Now that we have this, we can actually close the left pane because we don't need it anymore. And we're going to remove everything and leave our const dog object here. The first thing we're going to do is put in a function that takes the parameter by value. So function taking dog is taking the parameter by value here. And inside, you're going to see that we're going to set the name to our dog object, and we're going to say printful in the function body here. Let's use this function. Let's say function taking parameter by value, and notice that we are passing our const object as a parameter. We're going to say function taking dog and passing dog1. So what do you think will happen? This is a const object and we are passing it by value. Notice that the parameter is not const. So because we are passing by value, what we will have in the body is going to be a copy of this dog object that we passed here. So modifying it is not going to cause any problem because the changes we do in the body of the function are not going to affect our original const object. So the constness of the original thing is going to be preserved. If we try to compile this program in GCC, we're going to see that it's going to work. We're not going to have any problem. And if we bring up a terminal to run this program and run rooster, try to think about what we're going to get. We have a const object here, and I actually think we should also printful before we call the function because this is going to be better. We're going to say dog1 and say printful, and we're going to be able to see that the memory addresses, we can't call the printful function because it could potentially be modifying our const object. This is really bad. So let's not do that. We can run the program as is now. So we're going to run rooster, and we're going to see the memory address inside to be ending in D50. We're going to see that the name has been changed from the inside of the function, and we're going to print the information after we apply the change. To really prove that this is a copy, we could try and print the address ourselves from the outside of this function here. So we could say stdcout address of object, and we're going to put that out. We're going to say address of dog1, and if we build, we're going to see that. Let's build with GCC. Okay, so let's clear and run rooster. We're going to see that the address on the outside ends in DE0 and the address on the inside ends in D50. So they are two different objects because they live at two different memory locations. And the main message here is if you pass a const dog object as a function parameter to a function that takes its parameter by value, the code is going to compile and you are going to be allowed to do anything in the body of the function because the function will be basically working on a copy, and the changes you do inside the function body are not going to affect the original object. So this is what I want you to see here. So this is going to work. Okay, so let's comment this call out. And we are going to go on top and put in a function that takes the parameter by reference. We're going to put this in and let's say reference properly. Reference. Okay, so this is a function we're going to set up to do stuff with it. And we will try to use it with our const object here. So let's do that. It's going to be called function taking dog ref. Let's call it. We're going to go down here and do that. And we're going to try and pass in our dog object here. The moment we do that, we're going to get a squiggly line. And this is going to say qualifiers dropped in binding reference of type dog reference to initializer of type const dog. So what this really means is if the compiler allowed this to compile, this is not a const reference. So this is a non-const reference. So it could potentially be used to modify the parameter that we pass to it. And the compiler is going to prevent us from doing this because we don't want to modify our const object here. That's the reason. So this is not going to compile. We're going to get a compiler error. So we're going to build this and pass this through GCC to really let you see this. And we're going to get the same error we have seen before. We're going to try and bind a reference of dog reference type to const dog, and this is not going to work. Again, from the context of this function call, our const dog object here is really not working. You can't use it in this function here. Okay, so if we try and pass our parameter by const reference, so this function here is going to seem to work. Let's go down and say that here. We're going to copy the name of this function because I don't want to type all this here. We're going to put it in place and we're going to pass in dog1. And if we issue a call like this and we're not doing anything in the body of the function, if we try to compile, you're going to see that code is going to compile fine because the parameter is const reference. So this const reference is really going to protect the constness of the object here because we can't go through it and modify the object. But if we uncomment what we have inside here, we're going to get a compiler error, which is expected on the first line here. But because we can't really go through this const reference to modify the object. But the problem is the second line here is also not going to compile because the compiler doesn't really know that the print info function here isn't modifying our object. So it's going to throw an error here. Let's do that. We're going to build this with GCC and show you these compiler errors. You're going to see that we have a problem with our setName function, but we also have a problem with our printful function because they all use the this pointer, and the this pointer could be used to modify the object. So the compiler is not going to allow us to use a function like this. And again, our const object is really useless. In the body of this function, we can't read from it. We can't write data into it. We can't really do anything with it. So it is useless in this context here. So this is the problem I want you to be aware of. Okay, so we have seen that references aren't really going to work. What about pointers? Let's pass a parameter which is a pointer to non-const. And we can set up a function like this, which is going to take a dog pointer parameter. And if we go down and try to call this function, you probably know what is going to happen. The compiler is not going to allow us to even call with the address of our dog object here. The moment we do this, we're going to get a squiggly line, and Visual Studio Code is going to say the error here is not clear. Let's pass this through the compiler and see the compiler error. And it is basically going to be the same thing we have seen before. It's going to say invalid conversion from const dog pointer to dog pointer. So what we have in our function parameter here, or as a function argument, is a const dog pointer because it is pointing to a const object. But our function here is taking its parameter clearly as a non-const. And this pointer could potentially modify our object So the compiler is not going to allow this call here to compile. We can't use this. Okay, so this is not going to work. And if you try to pass your parameter by pointer to const, we're also going to have problems. So let's go down and put in our function here. It's going to be called function taking pointer to const dog. And the parameter is going to be taken by pointer to const here. If we go down and call our function, let's comment out what we have in the body, show you that this is going to actually compile. So we're going to call the function here, and we don't want the entire thing, we just want the name of the function. Sorry for this. So let's take out the void thing here. We just want to call our function, and we're going to give it the address of our dog object. So we're going to say dog1. If we try to compile this code and we're not doing anything in the body, the code is going to compile. And try to think about why. Why do we have a problem here? Build finished with errors. And which problem do we have here? We have a const dog reference, and we are trying to go through it to modify stuff here. So this is going to give us a compiler error. This function here wouldn't compile. This is the problem here. And we're going to build again. You see that we also have another compiler error. So what is the problem here? We have unexpected unqualified IDB full return. And we're going to see that we have the problem at line 52. Let's go there. A curly brace here from the function that we had. That's the problem here. So what we're going to see is that this function call here is going to compile. Let's do that. We're going to pass this through GCC. Now the build is good. But if we go in the function body and try to do anything, for example, we try to set the name, this is not going to work because we can't go through a pointer to const and modify the object we are pointing to. So this is not going to work. But our printful function is also not going to work because the compiler thinks we could go through this function to modify our object through the this pointer, because that's going to be a pointer to the current object. And if we try to compile, we're going to get a weird error, which is basically going to say that we could go through the this pointer to modify our object. It's going to say that this pointer could be used to modify our object in set name, and it's going to say the same thing in the printful here. Printful, we have a problem because we're not using pointer access notation. So let's fix this a little bit. But we're going to build again, and we're going to get the same error basically. We're going to say that this pointer could be used to modify our object from the printful function. This is what the compiler is saying here. And you see we have the same problem in set name, that this pointer could be used to modify our object. So what I really wanted you to see in this lecture is that you have to be careful if you want to use const objects of your classes. The object is almost going to be useless because the compiler is going to think your getters have potential to modify the object and your setters have the potential to modify the object. And the compiler is going to really stop you from using these guys, and your objects are really going to be useless. This is really bad, and we're going to see how we can solve this problem starting in the next lecture. Go ahead and finish up here and meet me there.